Welcome to the how-to video for creating a hydraulic fracture using CMG's hydraulic fracture wizard. This video will go through the process of adding hydraulic fractures to this predefined horizontal well. To start the process, I'll navigate to the hydraulic fracturing option located in the wells and recurrence section. So first, I'll click on the wells and recurrence section in the tree view, click on the arrow besides wells and recurrent, and then select the option hydraulic fracturing. So in this window that opens up, there are three tabs here at the top. And the first thing I'm going to do is click on the NonDarcy option tab. It is very important to actually enable this NonDarcy option because the high permeability nature of the hydraulic fracture causes the flow of gas to become turbulent. At this point, the default Darcy law equation is no longer an accurate way to calculate the flow rate, and due to this, the non-Darcy correction factor needs to be used to calculate a more correct rate. In this wizard, there are 4 different correlations that are available for the non-Darcy correction factor. And in this case, I'll select the general correlation, and then I'll click Apply at the bottom. Next, I'll click on the Templates tab at the top. Here, you can create as many templates as you'd like to define your fracture properties. If all the hydraulic fractures in the simulation have the same properties, you only need to create one template. If each well or fracture stage has different properties, then the corresponding number of fracture templates need to be created. In this case, though, I only want to create one fracture template, and I can do so by clicking on this green plus option. So every time I want to create a new fracture template, I can just click on the plus option and a new planar template will be created. And the first thing I'm going to do here in this fracture template is change the name to HF_1. And in the sections below, the properties of the fracture need to be defined. So first, I'll specify the fracture width to be 0.001 feet. And I'll set the intrinsic permeability to be 10,000 millidarcies. When this is done, the wizard will automatically calculate an effective fracture permeability. This is done because in real life, the width of the fracture is extremely small, and having this small of a grid block in a numerical simulation tends to cause a lot of issues. So to avoid this, Builder will increase the fracture width to 2 feet and then recalculate the permeability in a way such that the total fracture conductivity is conserved, which is what is truly important at the end of the day. So the recalculated value of permeability is the effective permeability, as you can see here, and this is what the simulator will use as the permeability of the fracture. You also have the option of defining a tip permeability if the permeability of the tip of the fracture differs from the rest of the fracture. The next thing I'm going to do is define the direction of the fracture, and this can be done by scrolling down. And here in orientation, I'll select the direction to be in the J direction. And this is done because I want the fracture to be perpendicular to my well. For the number of refinements, I'll set it to be 7 in the I and J direction, and I'll leave just 1 refinement in the K direction. And I'll talk a little bit more about these refinements once the fractures are added in, but the main purpose of these refinements is just to improve the accuracy of the fracture. The next thing I'm going to do is just scroll down and then specify the half length of the fracture. The half length is just the length of the fracture in each direction. So for this, I'll set it to be 350 feet. The last 2 things that need to be defined are the layers above and below the perforations that the fracture actually extends into. For the layers above, I'll specify 4, and layers below, I'll specify 5. And once everything's been defined, I'll click Apply. The last thing left for me to do is to apply this template to the well I would like to hydraulically fracture, and to do this I'll click on the Fractures tab at the top. To apply the template to well 1, I'll click on the date underneath well 1, and on the right side there are 3 different options. So the first option is New Planar Fracture Stage, the second option is New Complex Fracture Stage, and the last option is Import Fracture Stage. The Complex Fracture Stage option is useful if the goal is to create SRV type fractures where the location can be specified by microseismic data. CMG can also handle the import of fracture stages from different fracture software. So if you have data that's been exported from a third-party fracture software, you can import it into Builder as well by using this Import Fracture Stage option. However, the option I'll select in this case is the New Planar Fracture Stage, because this allows the creation of simple bi-wing fractures. So I'll click on this option, and in this window, I'm going to select the fracture template that I created earlier by clicking on the drop-down besides Fracture Template and selecting HF_1. So now this fracture template is going to be applied to this well. In the Select Perforations option, you have the ability of specifying the locations along your well that have been hydraulically fractured. In this case, I'll leave it at the default option of all perforated layers. Lastly, you can specify the minimum fracture spacing, or which slabs the fractures are limited to, which is effectively the perforation number. In this case, I'll set my minimum fracture spacing to be 100 feet. And now that everything's been defined, I'll click Apply. And now the fractures have been created. So I'll click OK to close the window, and as you can see, new fractures have been defined for this well. And the first thing I'll do is actually change the property to the permeability, and then I'll zoom into one of my fractures. So I'll just zoom in here. The red line that can be seen here is the actual fracture, and the permeability of this region is clearly higher than the rest of the reservoir. Also, logarithmic refinements have been added around the fractures, so there are more refinements around the actual fracture and less as you move further away. This actually helps improve the accuracy in the region that matters most and will lead to more accurate results. So this is how you create hydraulic fractures in Builder. Thank you for watching.